Welcome back, ladies and gentlemen. Looking at 1.2 equations with the variables on both sides. Now, a little bit redundant here with the objective, but it's to solve equations when the variable appears on both sides of the equation. Alright, well, here's going to be one I'm just going to kind of work through it, and then we'll start talking about particulars of what I did. Okay, I've got 7x plus 8 equals 2x plus 53. Now, what I'm going to do first is I've got this 2x, and I'm going to cancel him out by subtracting 2x from both sides. 7x minus 2x is a 5x. Okay, notice when I wrote the 2x, I made sure I lined it up underneath the 7x because those two were like terms. And then I'll bring down my plus 8. Okay, the equal sign's got to come down. That's very important. Some people tend to forget that. Forgetting that will mess you up, so please don't. And then there's the 53. Okay, now at this point, this looks like one of our two-step equations because it's exactly what it is. Alright, so at this point, hopefully you're kind of on autopilot where you look at that and go, oh, let's go minus 8 on both sides. Sounds good. 8's cancel, leaving with the 5x equals, that's 45. And then, of course, now we have a one-step equation. And dividing out the 5, now leaves me with the x, which again is technically a 1x, but we don't write that 1 most of the time. And then 45 divided by 5 is a 9. So I've got x equals 9 as my solution. Well, notice that our goal is still the same on that problem. We're going to just cancel things until the, well, hopefully you can guess before I even write it, but that's going to be the variable. Okay, now I said things to be a little bit vague on purpose, but we're going to either cancel variables or regular numbers until the variable we have is by itself. Okay, likewise here, 12x plus 13 equals x minus 86. Again, I just want to start canceling things out. So again, this is a 1x, and in case you like to write that in and do it, I don't require it from you, but there it is. So I'm going to subtract 1x from both sides. Again, I'm doing this now on the right side, and I'm going to go over to the left side now, and again, line up my like terms, and cancel here. 12x minus 1x gives me the 11x. Again, I just bring everything down that I didn't just mess with. In this case, a plus 13, an equal sign, and then be careful of this. This minus sign does have to carry through onto the 86. Alright, and at this point, I'm going to subtract the 13. And again, those cancel, and now that leaves me with an 11x. It's by itself on one side. And then negative 86 minus 13 gives me a negative 99. And now, hopefully again, pretty much autopilot here, we divide through by 11 and get x equals negative 9. Okay, now I promise you that not every answer is going to have a 9 in it, but there we go. Now at this point, of course, I've always canceled the variable term on the right side first. Well, do you always have to cancel the same term that I'm canceling? Well, let's see. Okay, well, it's a new equation, so let me keep doing it the way I've been doing it. I've got the variable on the right side, 7x. I'm going to cancel him out first by subtracting 7x. Gives me a negative 4x here after these guys cancel. Bring down my plus 15, bring down my equal sign, bring down my negative 9. At this point, I have a two-step equation again, so hopefully not too much explanation needed. We cancel the 15 by subtraction this time, so I have a negative 4x equals, and then this gives me a negative 24. Dividing through by negative 4, it appears that x equals 6. Okay, now what if I cancel the variable on the left side first instead of the right side? Well, so that means I have to cancel the 3x first. Alright, so I'll do that from both sides again, lining up my like terms, letting those guys cancel, having 15 equals 4x minus 9. And again, it's on the right side now, but we've solved equations like that, so hopefully that's no big deal. Add the 9 to both sides again, one on the left side and one on the right side of the equal sign. I get a 24 on this side. I've got a 4x, and of course the 9's cancel each other out. And then dividing through by 4, notice I get a 6 for my x. Again, it's just backwards basically, so I can rewrite it as x equals 6 if I feel like it. Although realistically, it is perfectly acceptable to say 6 equals x, but even though I'm happy there, I'm happier here. Woohoo! Anyway, just I think it looks nicer. Alright, well, let's keep working the same equation, but what if I don't cancel variables first? What if I cancel numbers first? Okay, well, let's cancel the, I don't know, what do you like, the right side number first. Let's do that. So I'll cancel the 9 by putting plus 9. Again, it's a like term with a 15, so that's the one I'm going to put it with first. So I've got 3x here plus 24 equals 7x, and the 9's have canceled. Okay, now this is a little bit weird, but notice that I've got variables on both sides still, and I like having variables just on one side, so I think at this point I'm kind of locked into canceling the 3x. And by doing so, those guys are gone. I get a 24 equals, let's see, 4x by subtracting those two guys. And then that should look kind of familiar, because that's what we just did a second ago, so I'm going to divide by 4, and I'm going to cheat a little bit here and write the x on the left anyway, and then put the 6 there just because I think that looks prettier. Okay, so I cancel the 9 first, and I still got the 6. Well, my only other option here is what if I cancel the 15 first? So I'll subtract the 15 from both sides, and I get 3x, those guys are gone, equals 7x, that's a minus 24 this time. Okay, but now again, I've got variables on both sides, so I do want to cancel one of them out. And I want to cancel the one that's kind of with the number, because it gives me less extra stuff floating around, I suppose. But whatever the case here, this gives me a negative 4x equals a negative 24. Now notice, by doing this, all I have to do is now divide. And lo and behold, I get x equals 6 again. Alright, so basically the rule of thumb here, the term you should cancel first is, well, I did this 4 times, canceling a different guy every time, so I got the same answer. So basically the term you should cancel is whichever one you feel like. Whichever one you feel like is fine, and as long as you follow the rest of the steps, you should get the right answer every time. Well, don't let negatives or terms that aren't in the regular order mess you up. The regular order, I mean, is the variable first and the regular number second. Right. Be sure to cancel things using the opposite operation and always line up with your like terms. I've been trying to stress that so far, but stress it again. Okay, so I've got this, and again, my normal pattern is I like to cancel the variable on the right-hand side, but really it doesn't matter. So I'm just going to stick with that for now, but as we just kind of discovered in those previous problems, you can cancel any one you wanted. So here I've got a negative 10x plus 13, and then those guys cancel, leaving me with an 83. Subtracting the 13 now gives me a negative 10x equals 70, and dividing through by a negative 10 gives me x equals negative 7. Okay, so having the negative on the 6 didn't really hurt things too badly. Just watch your signs when you are adding or subtracting things together. Okay, likewise here, I've got this 3x on one side, but then I've got the 5x, which is in the wrong order, if you will. It's not really the wrong order, but it's the unusual order, I suppose. So I'm still going to cancel the 3x. Okay, but again, notice I'm not going to write it under the 16, because it's not a like term with the 16. It is a like term with the 5x, so I'll write it there. Alright, again, same basic idea, those guys cancel. I've got the 16, now 5x minus 3x is a positive 2x. And I've got that minus 4, they can just come down. Now, same basic idea, if I've got a regular number and a variable term like this, I want to get rid of this regular number, this constant term first. And so since it's a positive 16, I will subtract 16 to cancel them out. Those guys are gone. I've got a positive 2x equals a negative 20 in this case. And again, at this point, it's a very simple equation. Just divide and get yourself x equals negative 10. Alright, now here's 3 more problems to give a try, and of course, as always, we'll go over these at the start of class tomorrow. We'll see you there. Bye.